that task are both the same endpoint, but the route will consider this thing as a different based on the request type, HTTP method. If it is get slash task, it will read all tasks. If post task, then it will create a task. Then again, we have put. Put is used to update the record. So we will use put task slash ID. So it will our route will understand that we need to update the task rather than read one task. Similarly, delete task ID, delete a task, and patch. Patch. The difference only between the put and patch is that patch is generally used when you want to update the single field, and put is used when you want to update multiple field. So here, update task, we are using this endpoint. We will allow to update multiple uh, properties of the task. And what are the properties of the task? Uh, so here, only the title, priority, and status. These three things we are considering to be a task. So using the put, we will allow ID is a unique key. We never allow ID to be updated. So, and the delete will delete the record, and patch status will update the status only. So let's implement the API endpoint. So we have created data.js. Now we will use these data.js. First, we will import it. So here, let me remove this. So here, app.get/task will return all the tasks, and tasks are coming from where? From the loaded data. So it is straight ahead. So here, one thing you will notice that whenever you write any code, and if you try to access it, you will get you will not see the reflection of the change. The reason is that when you run the node server.js, it doesn't reload the server when you change the code. In order to do that, node has a way. If you add the flag watch and then specify the file, then it will watch for the changes. So now you don't need to restart the server again and again after you make the changes to your code. So here you can see that when I'm requesting the task, I'm able to get the list of all the tasks. Similarly, here, the next thing what I'm going to write is get single task. So here, the request parameter, whatever the ID you want to, whatever the part of the ID, the variable, for example, let's say 2. If this needs to be processed, this information needs to be extracted, you use colon and the variable name. And then that variable can be accessed using request.params.id. So here, the information from the browser to the server can be sent in 3 ways. One is the request param, which is part of the route itself, which can be accessed using this. And then the other is request.query. So here, key1 equals to val1, for example, and here you can do so here, if you do this, and here you can see, in fact, you can directly go ahead and access the So here you can see you can access the value automatically. So here, GET request only allow you to access the uh, data sent via the browser to the server, either using the request parameter, which is part of the route itself, and the other is the query parameter. The third type is the request body, which can be only sent when the request is of HTTP type, post, put, and patch. If it is not post, put, patch, then the only way to send the request from the server, from the client to the server, is via the param, route param, and the query URL. So here, what we are doing is, whatever the param ID I'm sending in the route, it is considered as ID, and I am getting that ID. I'm converting it into int because my all my IDs are int, and then I am from the task list, which is list of these tasks. Dot find is a JavaScript function which can be used to match and find the object from an array. So wherever this condition matches, it will return that instance of the object and stop. So here, if I pass 2 and I'm checking t.id, so what it will do, it will first check this instance of the object. If id equals to 2, no. If id equals to 2, yes. So it will return this complete object, and I'm storing it in a variable called task. If not task, 404 error, task not found, that error will be shown or thrown, and it is upon the browser how it handles it. That is on your React client code, or else if it is successful, then 200 status will be sent. That means your React code will be sure that uh, everything was fine. So 200, 400, 404, uh, 500 error code, 500 error code, 501, 502, 503, 505. Those represent server side error, uh, something which indicates that during the operation server encountered some error. And 404 is something uh, a resource was not found. So there are different HTTP status code. You can look into it. You can search for different status code and what are its significance. So here, if 200, then the task is returned. So now let's see if I return, if I enter 25, you can see error, task not found. So now let's quickly add post, task post. So here, in our earlier request, we were listening for the route for the GET request. Here, in order to create a task, we are going to listen for post type. So here, as I said, there are three ways of receiving the content from the browser. One is the param, the other is query, and in the post, we get the data using the request.body. So here the task, in order to create the task, what are we going to do? We will get the request body and we will extract title, status, and priority from the body. And if title is empty, then we will say title is required, or else what we'll do, we'll create a new task object with new ID. We will determine here ID based on the task length plus 1, or the task length minus the last ID plus 1. And then In reality, the database manages the ID for you. You don't manually increment the ID in this way. So here title, we are setting the title from the request body. Status, if not set, we are setting a default as pending. Similarly, if priority is not set, we are setting it as low, and then we are pushing the new task to the existing task. So here the memory in memory array will update the add one more task to the list. Similarly, now let's see how to update a task. So here for that, we will listen for put, and we will also want ID for that. ID, we will fetch it from request.param.id. Using that, we will fetch the task. From the request.body, we will get the new task status and priority. What we'll do, we will just go ahead and update the title, status, and priority. And we will send the updated task to the browser. Delete a task. We will accept the ID from the param. We will fetch the index rather than getting the task. We will find the index of the task. And then if index not found, then if index is not found, then it is -1. 0 or more means that the index was found. And then we will do task.splice. Splice removes the element from the array at the index. And one specifies that from the index, how many elements needs to be removed. We want only that particular task to be removed. So we'll set 1. And we will again set 204. That is not 204 indicates that not modified. The task was not modified. So that's why 204. Batch. Update only the status of the task. Again, here we are going to listen on the param ID, and the endpoint will be with status. Status is not param, it is just hard-coded string. How we are going to fetch the status? We are going to fetch the status from the request.body, and we will check against the valid status. If status is from these value, using valid states include status. So whatever the user request a new status for the task, it checks whether the new status belongs to any of these. If it doesn't belong to these, then it will say invalid status, must be one of these. If it is one of these, then the status will be updated for this ID, and then the request will be sent. So notice the pattern. Every route follows find the resource, validate, respond with the right status code. This pattern repeats forever in backend development. So here, let's in the development. So let's say if you're working on the backend, it's easy to check the API endpoint for the GET request, but how to check the API endpoint for the post and delete request, or post, put, and the rest of the API endpoints. For that, there are standard tools like Postman and Hopscotch, and there are many API testing tools. So we generally use those tools to test the API endpoint. So let me start one of the tool, and I'm going to use Hopscotch. So here, what I'm going to do, I'm going to check the API endpoint. So I'm running it on 5000. Let's see task. So here I'm able to see the task. Now let me create a new task. So here there are total 3 tasks. So let me create a new task. For new task, I need to request to post, and the URL will be task without any ID or any param. In the body, we are going to put, uh, first of all, content type will be application.json. So it will tell the server to process the request body as JSON. Here, I have kept the title priority, mid, high, status. Let me keep it as, even if I don't keep status, default pending, it will accept it. So let me execute this. So you can see a new task was returned with ID equals to 4. So let me again check via the get request to see if the task was created. So you can see the task 4 is there. So now let me fetch the task 4. So you can see new task 4. Let me update the task. So for that, put, and I want to deploy to render server, for example. And here, let me put it. So you can see this got updated. Let me re-verify it. You can see that now the title got updated. Let's try the delete. So let's delete the task 4. So you can see 204 not content, no content. And let me get the list of all the tasks. So here you can see only 3 tasks are there now. So you can use the hopscotch and Postman to test your API endpoints. So now let's, so these are the standard HTTP status code. 200 means success. The request was success, and it is able to deliver. Server is able to deliver the response. 201 for, it is generally used for post request. 201 created. 204 no content is used for delete. 400 bad request. 404 not found. 500 a server side error. So now let's get back to our front end. Let's integrate these API to our front end. So in order to do that, let me first clone the uh, code, server code of our last, browser code, React code from our last session. So what I'm going to do, I'm going to create a new terminal, and in here, I will do git clone, and I will paste the URL. So here cd, I will do task to React. I will do npm install. It will install all the dependencies. So, so here, what are we going to do now is, if you run npm run dev, so here, So this is our last week's front end code. We here the all the tasks are in browser. Now we are going to integrate the API what we have just created. So first thing what we'll do is we will install Axios in our project. Axios is a library which simplifies the client server communication in order to make API call. So we can use fetch also, but Axios uh, gives more power and it makes customization much more easier by the help of writing hooks and uh, injecting middleware. A lot of things can be done with Axios. It is very powerful tool. So mostly in a production application, we use Axios for client server communication in the React application. So in our React application, what are we going to do? We are going to create a services folder, and we are going to create API.js. And API.js will have all the methods which can be utilized by the React application, and internally it will make the API request. So let's see how to create an API service. So here, the first thing is we are importing the Axios, import Axios from Axios, and we are writing this thing in our React application. We are not touching backend application. Backend application code run on the remote server. This is something which will run in the browser. So here we are importing Axios API base URL where the server, what is the server API endpoint, the root API endpoint. Generally, we don't hard code the URL or any configuration value directly in code. The best practice is to create .env file. But for the simplicity's sake, let's keep it over here itself. So after that, we can create the Axios client. We can create the Axios client with the following configuration: the base URL of the API server and the content type, what the server expects the body to be. So we are keeping it as application.json. After that, we can use API client to make different kind of requests. For example, get request, post request with the endpoint and the new data. For patch status, API client.patch with ID as a param and status is hardcode key, and with the request body with status. And delete task by ID. So delete task and the ID in the param. So these are the API and methods what we can directly now use in our front-end code. So now let's create new component. Earlier on, uh, excuse me. Earlier on, the task were initial tasks were hard coded in the home.jsx, and it was iterated in here, and the task card, each task was then rendered using the task card. Now what we are going to do is we are going to move certain functionality from here, and we will use task board, which will be container to task list. And now we don't need initial task and all those things. We will remove those as well. So first, let's create a new task board. So here We'll also create task module.css, which will have all the CSS, and taskboard.jsx. So here, so here, taskboard accepts props like tasks, which are list of tasks. Loading indicates whether when uh, so when you load the client, definitely it will take certain time, depending how far is your remote server. So during that time, it is best practice to let the user know that your data is loading. So while the data is loading, you can show the loading message. And if some error occurred during the server client communication, you need to show the error message also. So if tasks are loading, then show that loading message. If error are loading, if error occurred during the loading of tasks, then show the error message. Error message. If task is not there, then show no task are here. Add one above. And if tasks are there, then iterate over all the tasks. And for each task, show a task card. Task card, we are not going to touch it again. We are going to reuse the same task card, which accepts the task title, sorry, task object, which consists of task title and your priority and status. It also has button. So if you go in task, you will see that it here we are showing the priority. We are showing the title. We are showing the title. We are showing the priority, and we are showing the status. And the status can be changed using the drop down as well. And then we have the button to delete the task. So when we click on the delete button, it directly doesn't delete it. It triggers the event. It calls the on delete prop. On delete prop. So the task card will let the parent know that the user has requested to delete the task. So earlier on, you can see that handle delete task. So we were directly updating the task by filtering the task and updating the list of the task. So here we are going to keep the task card as it is because the internal behavior of task card is going to remain same. What are we going to do is we are creating the container, the task board. Let me rename it task board. Sorry, not task card, task board. Task board and the taskboard CSS. So taskboard, we were reviewing taskboard. So it shows the loading if it is loading error, and at the end it iterates over the task and on delete. Again, taskboard doesn't do anything with the delete. It lets the parent know that delete user has requested a delete or status change. And who loads the taskboard? It's the home page. So we are going to change the home page layout. So earlier on our home page, now we don't need few of the things. We don't need this. Uh, we now need taskboard rather than task card. Add task form we will use as it is. Task filter we will use as it is. And now we will import service method. Fetch task for fetching the task, create task, update task, status and delete task by ID. So here, initial task, we will keep it as pending, as empty. So what are we going to do? Uh, we have created empty array state task, which will be updated via the API. We will make a call to API using fetch task and update the state. Filter, we will keep it as it is. We will keep the filter internal. That is, filtering will happen in the client side. Loading and error are the new state which we will pass to the task board to indicate the loading and error. So let's first, so now let's we will remove handle task, delete task. We will remove these. Uh, Filter task also we will remove. We'll revisit what we need to do. So first thing, we need to load the task. So what are we going to do? We will going to write a function called load task, which will call the fetch tasks. So fetch task, what it does, it makes it uses Axios API client to make a request to slash tasks. And here we are using the promise. So since it is asynchronous request, so there are two kind of requests, the synchronous and the asynchronous. Synchronous means as soon as you invoke a method, you get the result. And then there is asynchronous. Asynchronous are kind of requests where while calling, you don't know when you will receive the body, because here when you are making API call, the request is sent to the server, request might fail, the server might take a lot of time. So those kind of, whenever the input output request kind of very, which requires heavy computation or network communication, so in that case we write those code in as an asynchronous method. And asynchronous method, when invoked, uh, directly doesn't give the response. We wait for it to return the response, and for waiting for the response we use dot then. There are two approaches to writing the asynchronous request. One is using this, otherwise the other way is to write async method to specify that this method is asynchronous method, which is going to use the asynchronous code. And then we will have to write a keyword called await. And then here, so here what will happen is fetch task can take any amount of time. Here the code will wait for the response, and after that you can proceed towards the response. And here, in order to catch the error, you need to use try catch block. And here you can specify the error also. And then you can do whatever you want to do with the error body. So this is one way of doing it. The another way is using then and catch. Oh, excuse me. So here, you make you call the method, an asynchronous method, then write then. So as soon as when the request is fulfilled, you will get the response. And this Axios returns the server data in data object. So what we are doing is when the server sends the response, this thing gets invoked. We are updating the state with set task. So new res.data will have all the list of tasks. So here we are updating the set task. So now the task will reflect the server task list. And if some error happen, we are updating the error, set error. So this error will get updated. And finally is called every time, irrespective if the thing was successful or if error occurred. Finally is every time called in a promise, and we are setting load equals to false. Set loading equals to loading will become false. And so here what we'll do, we will call the load task when the component is first loaded. So for that, we will use effect, and when we apply an empty square bracket, then that means that it is executed only once when the component, that is our home.jx, gets loaded for the first time. And in that, what we are going to do, we are going to call load tasks. And we will write few methods: handle add task, handle delete task, and handle status task. In that, we are going to call our API service create task from service/API, and we will pass the new data, and we will see the response.data will have the new task, and we will update our task state. We will add one more task to the task state. So here, this statement updates the task list. Delete, in delete, we are invoking delete task service, and then we are updating the task list by removing the task having the ID what we just deleted. Status update, we are locally updating the task state, and also invoking the API call update task status. Now the filter task list is going to remain same. So whatever the user has selected the filter, whatever the default filter is all, whatever the filter user chooses, based on that, the task is filtered. So this is going to remain same from our last code. Here, earlier on, tasks were hard coded. Here, task is updated from the load task when we make the API call, when the component is loaded. all these things are going to remain same. Handle add task earlier on just updated task, but updated the state, but now it is making an API call and then updating the state. Task filter bar is going to remain same. Now, instead of this, we are going to load the task board. The task board component, which we created a few minutes back. The task board component, we are going to pass the filter task rather than the whole task, the filter task based on the what the filter user has chosen. The tasks are getting filtered over here, and we are passing those tasks, a subset of the task. We are passing the loading prop, error prop, and on delete handler and on status change handler. So now let's see these changes in action. So here, the UI and everything are same as compared to our previous session, but here we'll see when we are making a request, you can see API call was made for the task list, and here the task lists are getting returned. 3 task lists are getting returned, and these are being shown over here. Let me delete one task. So you can see delete request was made to /star/3, and no response body was returned because the response was 204, no content. Even if I try to refresh it, you can see only 2 tasks are being shown over here. Local filtering is working. I can go ahead and add new task over here. For that, you can see post request was made, and you can see it returned a new task, created task, and you can see learn React.js over here. And you can also update the task status. So if I change it to in progress, so you can see here payload was just status, and the status now got updated. And even if I reload it here, you can see the change. Now the only problem here is that we are not persisting the data. If the server restarts, if I close the server and restart the server, you can see this will go away. Why? Because we are storing, we on the server side, we have the default data set. We are reloading that thing and discarding the whatever changes we have made. And real application, we don't do that. We don't store things in memory. We do store certain things in memory, which needs very frequent access. For example, cache or key value based pair thing. But things which need a permanent copy, or if we want to persist thing, then we use database for those things. and we will learn about the uh, MySQL in our next session, and MongoDB, and we will continue from here, and in our backend we will integrate those things. If anyone has any question, they can go ahead and ask. All right, then I will end my today's session. The code, whatever we have done today, it will be shared across to you via email. Thank you for your time, and let's meet in our next session. Bye bye.